Our planet Earth is a dynamic place. From the vast oceans to the towering mountains, the Earth's surface is constantly changing. We might not always see it, but these changes are happening all around us. Earthquakes shake the ground, volcanoes erupt with fiery lava, and mountains rise towards the sky. These events may seem random, but they are all connected. They are all driven by the movement of Earth's tectonic plates. Imagine the Earth as a giant jigsaw puzzle. The pieces of this puzzle are called tectonic plates. These plates are not static, they are in constant motion. They move and interact with each other, shaping the Earth's surface over millions of years. The study of tectonic plates is a fascinating journey into the heart of our planet. It helps us understand the forces that have shaped our world and continue to shape it today. By understanding tectonic plates, we can better prepare for natural disasters and appreciate the incredible power of nature. So let's embark on this journey and unravel the mysteries of Earth's moving puzzle. The tectonic plates. Before we delve into tectonic plates, we need to understand the Earth's structure. Imagine the Earth as a giant peach. The skin of the peach represents the Earth's crust. This is the outermost layer of Earth. It is the ground we walk on, the ocean floors, and everything in between. Now imagine that the peach skin is not one smooth surface. It is cracked and broken into several pieces. These pieces are like Earth's tectonic plates. The Earth's crust is not one solid piece. It is broken into these large and small plates that fit together like a jigsaw puzzle. The Earth's crust is very thin compared to the other layers of the Earth. It is thinnest under the oceans and thickest under the continents. These plates are not just lying there, they are constantly moving, albeit very slowly. This movement is what causes earthquakes, volcanoes, and mountain ranges. It is what shapes our planet and makes it so dynamic. Tectonic plates are massive slabs of rock that make up the Earth's lithosphere. The lithosphere includes the crust and the uppermost part of the mantle, the layer beneath the crust. These plates are enormous, some spanning thousands of kilometers across. There are two main types of tectonic plates, oceanic plates and continental plates. Oceanic plates are denser and thinner, primarily composed of basalt. Continental plates are thicker and less dense, primarily composed of granite. These plates float on the semi-molten asthenosphere, the layer beneath the lithosphere. The interaction between these plates is a dynamic process. It is the driving force behind many of the geological features we see on Earth. Understanding these interactions helps us understand how our planet evolves over time. Now, you might be wondering what makes these massive tectonic plates move. The answer lies deep within the Earth. The Earth's mantle is extremely hot. This heat comes from the Earth's core, which is even hotter. The heat from the core creates convection currents in the mantle. Convection is the process of heat transfer through the movement of fluids. Imagine a pot of boiling water. The hot water at the bottom rises, cools down at the top, and then sinks back down. This cycle creates a circular motion in the water. A similar process happens in the Earth's mantle. The intense heat from the core causes the mantle material to rise. As it rises, it cools down and then sinks back towards the core. This continuous cycle of rising and sinking creates convection currents in the mantle. These convection currents act like giant conveyor belts, dragging the tectonic plates along with them. This is the driving force behind plate tectonics. Section 5. The Dance of the Plates. Plate boundaries. The movement of tectonic plates is not random. They interact with each other in specific ways at their boundaries, the regions where they meet. There are three main types of plate boundaries: convergent, divergent, and transform boundaries. At convergent boundaries, plates move towards each other. This can lead to collisions that create mountains, volcanoes, and deep ocean trenches. At divergent boundaries, plates move away from each other. This allows magma from the mantle to rise and create new crust, forming mid-ocean ridges and rift valleys. Transform boundaries are where plates slide horizontally past each other. This grinding movement can cause earthquakes. Understanding these interactions is key to comprehending the forces that shape our planet. Each type of boundary generates unique geological features and events, contributing to the Earth's ever-changing landscape. Section 6. Convergent boundaries, where continents collide. Convergent plate boundaries are the most dynamic and geologically active regions on Earth. At these boundaries, plates collide, and the outcome depends on the types of plates involved, oceanic or continental. When two continental plates collide, the immense pressure buckles and folds the land, creating towering mountain ranges. The Himalayas, for example, are the result of the ongoing collision between the Indian and Eurasian plates. This collision, which began millions of years ago, continues to uplift the Himalayas, making them the highest mountain range on Earth. These collisions are not just land-shaping events, they are also responsible for frequent earthquakes as the plates grind against each other. Understanding these processes helps us appreciate the immense forces at play beneath our feet. Section 7. Divergent Boundaries, the birth of oceans. Divergent plate boundaries are regions where plates move apart, creating new crust. This process is most evident in the mid-ocean ridges, vast underwater mountain ranges that encircle the globe. At these ridges, magma from the mantle rises to fill the gap created by the divergent plates, solidifying and forming new oceanic crust. As new crust is generated, the older crust is pushed away from the ridge, causing the ocean floor to spread. This process, known as seafloor spreading, is responsible for the continuous movement of continents over millions of years. The Atlantic Ocean, for instance, is growing wider as the North American and Eurasian plates move apart at the mid-Atlantic ridge. Divergent boundaries are not only found in oceans, they can also occur on continents, creating rift valleys like the East African Rift, where the African continent is slowly splitting apart. Section 8. Transform boundaries, plates sliding past each other. Transform boundaries are regions where tectonic plates slide past each other horizontally. Unlike convergent or divergent boundaries, there is no creation or destruction of crust at transform boundaries. However, these boundaries are still geologically active and are notorious for causing earthquakes. The San Andreas Fault in California is a prime example of a transform boundary. It marks the boundary between the Pacific Plate and the North American Plate. These plates are sliding past each other, causing stress to build up in the rocks along the fault. When this stress exceeds the strength of the rocks, it is released suddenly, causing earthquakes. Understanding the movement along transform boundaries is crucial for earthquake prediction and hazard mitigation, especially in densely populated areas like California. Section 9. The Ring of Fire, a testament to plate tectonics. The Ring of Fire, a zone of intense volcanic and earthquake activity encircling the Pacific Ocean, is a testament to the power of plate tectonics. This 40,000-kilometer arc is home to over 75% of the world's active and dormant volcanoes and is responsible for about 90% of the world's earthquakes. The Ring of Fire's intense geological activity results from the interaction of multiple tectonic plates. Along its boundaries, plates collide, diverge, and slide past each other, generating earthquakes, volcanic eruptions, and tsunamis. The Ring of Fire is a stark reminder of the dynamic forces shaping our planet and the importance of understanding them. Studying the Ring of Fire provides valuable insights into plate tectonics and helps us develop strategies to mitigate the risks associated with these natural disasters. Section 10. Unveiling Earth's Secrets, Scientific Discoveries. The theory of plate tectonics revolutionized our understanding of Earth. It emerged from the earlier hypothesis of continental drift, proposed by Alfred Wegener in the early 20th century. Wegener suggested that the continents were once joined together in a supercontinent called Pangaea and have since drifted apart. However, Wegener lacked a mechanism to explain how the continents moved. It wasn't until the mid-20th century, with the discovery of seafloor spreading and the development of the theory of plate tectonics, that a comprehensive explanation emerged. Today, plate tectonics is a unifying theory in geology, explaining a wide range of geological phenomena. Through scientific exploration and technological advancements, we continue to deepen our understanding of plate tectonics, unraveling the mysteries of Earth's dynamic history and present. Section 11. Conclusion: Tectonic Plates and Our Future. Tectonic plates are the architects of our planet's surface, constantly reshaping it over millions of years. Understanding these powerful forces is crucial for predicting and mitigating natural disasters, managing natural resources, and comprehending the Earth's dynamic systems. By studying plate tectonics, we gain valuable insights into Earth's past, present, and future. We can better prepare for earthquakes, volcanic eruptions, and tsunamis, saving lives and property. We can also understand the formation of mineral deposits and fossil fuel reserves, essential for our modern society. As we continue to explore our planet and beyond, the knowledge we gain from studying tectonic plates will continue to shape our understanding of Earth and our place in the cosmos.